Today, for the third lesson, we are going to be moving away from expressions and moving into equations. So now, since we're dealing with equations, our directions will move away from evaluate or simplify, and now we will be looking to solve linear equations. And basically, solving a linear equation, what we're trying to do is to isolate the variable that is given to us. And so we're given a number of properties or ways to remove numbers and using different operations and to gradually get the remaining variable by itself. And so we need to take a little time to take a look at that. Now, this should be pretty straightforward. It's an Algebra 1 topic, and so this should just be a good review of what you learned how to do back in Algebra 1 and a little bit in pre-algebra. So be sure you're familiar with the terminology. You can see in bold and know how to work these. So let's take a look a little closer here. If we want to solve an equation, we want to get rid of values. What we need to do is we need to find a way to eliminate these values to isolate the variable. And so if you may recall from previous classes, you may have heard it called the golden rule of algebra. And what the golden rule of algebra is basically is whatever you do to one side of an equation, you must do to the other side of an equation. Now, one of the things that you also want to keep in mind is if you start a problem with an equal sign, you must finish the problem with an equal sign. If we're dealing with expressions, we have no equal sign. So we don't have an equal sign ever in the problem. It just finishes in a simplified form. But in equations, we start with an equal sign, so we want to finish with an equal sign. And you can see each of these properties, whether it's addition, subtraction, multiplication, or division, you are basically doing the same thing to each side of the equation. And so you can see just through the highlighted actions, every single time the equation is changing because we are doing the same operation to both sides. And so that's the golden rule of algebra. Whatever you do to one side, you have to do to the other side as well. So let's take a look at our first example here. In example number 1, excuse me, we have 3/7 x plus 9 equals 15. And so we want to start to peel away the parts away from x. Now, anything that's directly attached to x through multiplication or division is going to take place last, unless we have some parentheses to deal with. So we'll start this process by eliminating the 9 from the left side. So we want to eliminate the 9 from the left side, and the way we do that is by subtracting a 9. So a positive 9 and a negative 9 gives us 0. But the golden rule of algebra says if we subtract something from one side of the equation, we should also subtract that from the other side of the equation. And so you can choose to write this out, or you can choose to work that in your head. Either way is fine. What we have in effect is an elimination or a canceling of those 9's, and then of course 15 minus 9 equals 6. Now, we see this last step, 3/7 times x. So anytime we have a variable right next to a number with no operational sign, you'll recall that that simply means multiplication. We could do this in 2 steps if we wanted, but we're going to pick the simpler method of multiplying by its reciprocal. And so if we multiply by the reciprocal, what happens is the 7's on top and bottom cancel each other out, and the 3's on top and bottom cancel each other out. Now, of course, if I multiply 7/3 to the left side, I also have to multiply those times the right side. And when I do that, I multiply it times 6, and it's going to leave me with x is equal to 14. And we can see here that the x value is isolated, and so that would be the end of our steps. So that should be a good review of a number of skills that you learned in Algebra 1. At this point in time, why don't you go ahead and pause the video and work Part A of sample problem number 1. Use the example above as needed, and get x by itself. If you notice, there's something missing with these problems. It's kind of implied that you should be solving for x. Technically, the directions should say solve above both of them and telling you that your job is to get x by itself. If you see a problem like this without directions, it's implying solve for the missing variable. And so sometimes we'll use a y or an a or b other than x. So we'll get started. First thing we want to do is we want to add 14 to both sides. Now you can see that I've chosen to use the method of stacking up the 14s. If you want to do that step in your head, you're more than welcome, and I'm going to recommend that as you progress through Algebra 2 that you'll definitely want to start doing those steps in your head. The problems tend to get a little bit lengthy, and it'll just save you some space. So negative 14, positive 14 cancel out, simply leaving 5x on the left side, and then we are left with 35 on the right side. Now 5x equals 35. 5 is being multiplied by x. The way we undo, I guess if you could say, break apart multiplication is through the division process. So I'm going to divide by 5, and if I divide one side by 5, I must divide the other side by 5. So these 5's will cancel out, leaving me simply x is equal to 7, and I've solved for x in that problem. Alright, very good. Part B is very similar. I'm going to start by subtracting 6 from both sides. Now, I'm going to do it in my head this time. So if I subtract 6 from the left side, I know that those 6's cancel out. If I subtract 6 from the right side, I have negative 21 and negative 6, which is going to give me negative 27. Now I have 9 attached to the x through multiplication, so I'll undo this with division. Again, I'm going to do this in my head this time. So if I divide the left side by 9, I'm just simply left with x. And if I divide the right side, I'm left with negative 3. You can see how, comparing part A to part B, how doing some of the simpler steps of algebra will clean up your work and be able to do it in a lot less space. This will be a very important skill that you will want to retain for later whenever the problems get a little bit longer. Okay, that was a quick introduction to solving equations. We will look at some more in-depth problems as we go along through the videos.